Okie dokie. So in the last video we went through problems 1 through 6. It didn't seem like there was anything too bad with that, except for maybe problem 2 had complex numbers on it, and I know nobody really likes to deal with complex numbers. But that one wasn't too bad of a problem. But now they're going to get a bit more difficult. So starting on problem 7 now. Already just looking at this, I know that I don't want to deal with it. So m is equal to some big long expression times p, it looks like, okay. The formula above gives the monthly payment needed to pay off a loan at r annual interest over n months. Which of the following gives p in terms of m, r, and n? Okay. So if I look back at this problem, or the equation that they've presented to me, and then I reread the question, find p in terms of m, r, and n. So really all they're asking me to do is to isolate p in this equation. And the only place that I see p is here at the end. So it's something, some massive calculation times p. So if we just look at it that way, anything times something, the opposite is to divide by that thing. So that's how we're going to proceed through this. So let me start that out. So if m, just to simplify this, I'm going to rewrite this as a over b times p. So if we just simplified it to that, where a is the top part and b is the bottom part, then we would multiply both sides by b times b, and then m times b is m times b, and that's kind of obvious. A times p over b times b is going to be a, well, I'm going to put p on the numerator, times b over b. And the reason I can do that is fractions. I'm just multiplying these, so I can put p up top here, and then we multiply by b as well. And now it should be obvious that the b's are going to cancel out. So this is really a times p. And now I want to isolate p again, so it's being multiplied by a, so I have to undo that. So I'm going to divide both sides by a, So I'm going to get m times b over a is equal to a times p over a, which is going to cancel out, which is exactly what we were intending on doing. So now we have just p, and p is equal to m times b over a. And so what I noticed is the denominator became the numerator, and then the numerator became the new denominator. And I can actually rewrite this too. I can write it as m times b over a, and just take it out of the fraction. So this thing just flipped, which kind of makes sense, because to undo a fraction, you multiply by the reciprocal. So going back up to this huge problem that we had here, p is going to be, answer choice B, it looks like, because the top became the bottom, and then the bottom became the top, and then times m. So it looks like that works out. So it's going to be answer choice B. Do not freak out over this, because this was a pretty massive equation, but it turns out that it's just something times p, and we know how to undo that. So it just looks scary on initial notice. So going to the next problem, we have 8. If a over b is equal to 2, what is the value of 4 times b over a? Okay. So upon first instinct, I would probably think, let's just solve for a in this first equation and then plug it in here into the second expression. So how do I solve for a? Well, it's being divided by b, so I'm going to multiply both sides by b. So a over b times b is equal to 2 times b. That's after multiplying both sides by b. Then the b's are going to cancel out, so I get a is equal to 2b. Okay, so far so good. And I have 4b over a, which is 2b. So I just substituted 2b in for a here, that's all I did. And I noticed that I have b on the numerator and b on the denominator, so that's going to cancel. And then I have 4 divided by 2, and that's just going to be 2. So that's going to be answer C. Another way that you can do this, if you're curious, is to notice that we have b over a, but we had a over b here. So we can actually invert this expression, and we can do that because this is an equation, so as long as we do it to the other side, we can do it. So let me rewrite this. A over b is equal to 2 divided by 1. This way it becomes more obvious how the fractions work out. And so I'm going to invert the left side, and that's going to invert the right side. So I get this, and now I know b over a is 1/2. So for b over a, it's going to be 4 times b over a, and I know that b over a is 1/2. 1 second. Sorry, that was my phone. I'm a very important person, very many people calling me at all hours of the day. And so we have 4 times b over a is 1/2, so 4 times 1/2, well, 4 times 1/2 is just 2. So we get the same thing. And I think that was about as difficult as the first way of doing it. But anyway, that kind of confirms for us that it's definitely 2, because we managed to solve it in 2 different ways. Okay, so number 9. Okay, the first thing I notice immediately is that this is a system of linear equations. So this is really a Algebra 2 or Math 2 level class, or like a sophomore level mathematics thing. What is the solution to the system of equations above? Okay, so if you remember from class, the way that we can do this is, there's 3 ways to do it. Graphically, substitution, and elimination. And graphically is the easiest way of doing it if you have a graphing calculator, but we're not allowed to have a calculator, so that's out, because I am not drawing this out. It will not be precise enough, and I won't be able to tell what in the world is going on. So that leaves us with substitution and elimination. And for the most part, I just go with substitution because it's easier, in my opinion. So the way that we do substitution is, we notice first off, system of linear equations. So we have 2 equations and 2 unknowns. The unknowns are x and y. And so the traditional algebra expression is something like, I don't know, something like this, where you have 1 equation and 1 unknown. And with that setup, you can always solve for the unknown. In the case that you have 2 unknowns, you really need 2 equations, and you'll be able to solve it that way. So the way that substitution works, let's start applying this, is we're just going to solve for the x or the y and then plug it into the other equation. That's it. So nothing too fancy there. I notice that we have a minus x in the second equation, and so it's almost isolated by itself already. So I'm going to start with the second equation, -19, and I want to isolate x. So I'm going to add an x to both sides, and that way I get it on, well, it's at least not negative anymore. So -19 plus x is equal to 2y, and then I'll just add 19 to both sides, and that will get rid of the -19. So x is equal to, so -19 plus 19 is 0, 2y plus 19 is 2y plus 19, and now I have an expression for x. And we're probably going to add some more paper for this one. And now that I have an expression for x, I'm going to plug it into the other equation. So the other equation is 3x plus 4y is equal to -23. And I know that I know what x is, so I'm just going to plug it in now. Anytime you plug in a value, I would advise putting it in parentheses, because that will prevent confusion later on. Plus 4y. So this was the substitution step. This x became 2y plus 19 because x is equal to 2y plus 19. And now it should be obvious, I have a 3 out front, I'm going to have to distribute that. So 3 times 2y is 6y, 3 times 19, oh, yeah, I might not know that off the top of my head. It's 57, but let's actually do it out here to make sure. So 3 times 19 is, so 9 times 3 is 27. Hopefully we memorized our multiplication tables. 3 times 1 is 3, plus 2 is 5, so 57. So 6y plus 57. Okay, so then after distributing it, I get this, and then everything else in the equation is the same as before. plus 4y is equal to negative 23. And now if I look at this, I notice, okay, I have one equation and one unknown. So there's just the y. The x has gone now. So now I should be happy. I should know how to solve for y. 6y's plus 4y's is 10y's. So I have 10y plus 57 is equal to negative 23. And now I want to isolate the y. So I have to do, I'm going to subtract 57 from both sides. Minus 57. And that will give me 10y on the left-hand side. And on the right-hand side, I have negative 23 minus 57. Oh my goodness, okay. I'm going to take the negatives out. What's 23 plus 57? That's going to be 5, 6, 7, 8, so 80, but they're both negative, so it's really negative 80. If two negatives get added together, you get a bigger negative, so that makes sense. That's equal to negative 80. And y, and now divide both sides by 10. So divide by 10, divide by 10, and y is equal to negative 8. And now I'm going to go to here, and I'm going to see that I have to solve this, the x comma y, so I have to find x as well. But if I look at the answer choices, I notice immediately that there's only one y value that's negative 8, so it's going to be answer choice B. For the sake of completion, I am going to actually solve for x, and I know what y is, so I'm happy about that. And I just have to find what x is. So let's use the second equation. If I plugged in this value for y, I will be able to solve for x. So let me rewrite it here. 2y minus x equals negative 19. Y is negative 8, so 2 times negative 8. Notice when I substitute, I put it in parentheses. That way I don't get confused on where the minus sign goes and stuff like that. There's negative 19. And now I have an expression that only has one variable in it, so I can solve for x. 2 times negative 8, negative 16 minus x equals negative 19. I'm going to add 16 to the left-hand side. I'm going to add 16 to the right-hand side. I'm going to get negative x. And then negative 19 plus 16, that's minus 3. And now I have to negate both sides, or multiply both sides by negative 1. Think of it either way. And x is equal to 3. So x is equal to, let me box that. Since I boxed y, I'll give x the prestigious value of being in a box. So x value is 3, the y value is negative 8. If you really wanted to, you could plug these into this into both of these equations and see that they are true. So if we said 3 times 3 plus 4 times negative 8, we would find that to be negative 23, which is what it says it would be. And then the same thing for the second equation. Okay, so that was a rather time-consuming problem, actually. Systems of equations, you might hold those to the end of the test when you have extra time. Okay, problem 10. Oh, I'm spending too much time. Okay, I'm going to go to the next video.